moments. So in math as well, we have got moments in as much as we have moments in physics as well. So the first moment is known as the mean. The first moment is known as the mean. So the mean is the first moment. It is also known as the expected what? Value. So the first moment refers to the mean or the expected value and is denoted by EX like that. And this is the mean. So if someone says compute the mean, compute the expected value, compute the first moment, compute the average, they are simply asking you this one thing. Different words but one thing. So this is computed by, it's also denoted by mu x, that's the moment, mu x. It is in the discrete setting, this is represented by the sum of, or the sum from 1 to x of xi times the probabilities. You remember in physics, moment is what? Distance times force. So in this sense, it's your variable at that point times the probability. So example, so if you are rolling a die, you have got this probability distribution. So if you roll a die, this will be a probability distribution, and your first moment will be given by the sum from I equal to 1. So from I equal to 1 up to n. So in this case, our n will be 6. So this will be the sum of I1, which is 1 times this. So this will be 1 times the probability for I1. So you are multiplying these two, and then you add, multiply these two, the sum, and then multiply these two, which is, and then you multiply the sum of this, and then you sum, multiply this, you sum. That's how we compute moments. So it's the random variable times x, and then we sum all this in the, this will be in the discrete setting, and if you do that, you get the mean or the expected value to be 21 over 6. And then the first moment or the mean of a continuous random variable is given by x times the probability of x, and this one for continuous we are integrating from minus infinity to infinity. So if we are given a uniform variable from 0 to 1, and you remember that a uniform variable, we showed you an example. So this one spans from 0 to 1. So from here you can determine your variable, which is given by px, which is equal to 1, b minus 1, b is 1, a is 0, so this will be 1. Your probability function will be given by 1. Px is equal to 1. So this means that your mean will be integrating x times 1, because px is 1. For dx, so this, you integrate this, you get 1/2 minus that squared if you substitute, because if you integrate this, you get x squared over 2. Then substitute the limits from 0 to 1, lower limit and upper limit, and then satisfy yourself that that will be your mean for the continuous random variable. And then the second moment has got a special name. It is known as the variance. The second moment is known as the variance, which is represented by sigma x squared, and this is denoted also by E of x minus mu x You know how to compute this one, at least that. Huh? This is the mean. Huh? And then everything squared. So in the discrete setting, this is given by xi minus the mean squared times the probability. And then you are summing all those. And then in the continuous setting, you are integrating x minus the mean of x squared times the probabilities. So let's look at some examples. For example, let's look at the example. All right, so for example, let's try this one. This is known as the standard deviation. So let's start with this one. We have computed this one. This one was what? 21 over what? 21 over 6. Huh? Now we want to compute this one. So for us to compute, we need to compute the variance first. Eh? So the variance will be, variance x is equal to, remember, it's the sum of xi minus mu x. This should be squared times the probabilities. Eh? So this should be, in this case, this should be bracket, let's say xi is what? In this setting, 1 minus mu, which is 21 over 6 squared times the probability, which is 1 over 6, plus the next one is what? 2 minus 21 over 6 squared times the probability 1 over 6, and so on, plus and so on up to the last one, which is 6 minus 21 over 6 squared times the probability 1 over 6. So when you get your calculators, you do that, you should be able to find sigma squared, which is your variance. So this is the variance. And then from there, for you to get sigma, this, remember, this is the square root of, if you take the square root of sigma squared, you get this one. Hey, if you have got x squared and then they ask you to find x, what do? The square root, you take the square root. So if you have got sigma squared and you want to find sigma, just take the square root of this so that you get this sigma. So you are taking the square root of that to get that, and this is called the standard deviation. Sigma x only is sometimes is also called the standard deviation. So someone asks you to compute the standard deviation, they are asking you to find the square root of the variance. And then from there you can compute the coefficient of variance, which is given by sigma x over this one. So make sure you complete that. So usually what I do with these distributions, usually I give presentations. Students should present on these distributions. So the same culture will continue as well. Make sure you go and read basic knowledge and also get some examples of those distributions. Work out some few examples from those distributions. Of great interest, make sure you look at the uniform distribution I have covered already. I've given you some examples of the uniform distribution. We have covered this one. And then the normal distribution, go and look at the normal distribution, the standard normal distribution, the binomial. Make sure you NP, you look at this one with closely. Look at the Poisson distribution closely. Look at the Poisson distribution closely. Yeah. The normal distribution as well. If I can rank the importance, start with the Poisson, follow with the normal distribution in terms of putting specific importance. The binomial distribution is also important and applicable in your field, so you need to know it as well. The uniform distribution is important, that's when everything starts for you to understand how these things are in their settings.